All right, welcome back. So today we are in our 5-1 nth roots, and we are going to start where we left off last week with now moving on to simplifying. So when I'm simplifying radicals, what I want to be aware of is to pull radicals out, they have to be the same root as the exponent. And what I mean by that is I can take out for square roots, that's why I start with those, things that are perfect squares, or in other words, when they're squared, they equal that same value. So like we're going with the premise that the square root of x squared is x. Or let's say I was dealing with the square root of x to the fourth is x squared. Why? Because if I went the other way, x times x gives me x squared, or x squared times x squared gives me x to the fourth. So what happens when we have some things where they don't completely simplify out is we can pull out the things that are perfect squares, but what we have to do is leave underneath the radical the things that are not. And so I'm going to choose to do this by rewriting these as even exponents. Now to show you why. So the square root of a to the third, I'm going to rewrite as a squared times a. Why? Because there is nothing that I can multiply by itself to get a to the third. However, if I went one exponent down and had a squared, I could take that out because a times a is a squared. I'm not going to do anything with b to the 20th because it's already an even exponent. Then I'm going to highlight the things that I can simplify. I can simplify a to the second, and I can simplify b to the 20th. The square root of a to the second is a. That's going to come out of the radical. The square root of b to the 20th is b to the 10th. b to the 10th times b to the 10th gives me b to the 20th. So b to the 10th comes out. Those now are no longer inside the radical because we simplified them and they came out. So what's still underneath is a. And so this would be the most simplified. A b to the 10th times the square root of a. Okay, let's try to do this now with some numbers and variables. So I am going to rewrite all of these if needed. This is 2. And I'm going to rewrite 32 as the highest perfect square that goes into 32. And again, if you want your root card from the other day, or you can flip back to our note page from day 1 right here if you want to look at your perfect squares. They're right there. In a minute, we're going to look at perfect cubes. The highest perfect square that goes into 32 is 16, so I'm going to write it as 16 times 2. I'm going to write x to the 5th as x to the 4th times x to the 1st. Y to the 4th is already an even power, so I'm going to leave it. Z is not, I'm not able to write that as an even power, so I'm going to also leave that. All right, so what are the things that I can take out of the radical? I'm going to be able to simplify the square root of 16, the square root of x to the 4th, and the square root of y to the 4th. So I take those things out. The square root of 16, the square root of 16 is 4. Along with that 2, that's going to make this 8. Okay, oops, I'm sorry. I need to fit more things into there. The square root of x to the 4th is x squared. I'm just going to rewrite it down here. So at 8, and I have x squared. The square root of y to the 4th is y squared. And underneath the radical, I have a 2, an x, and a z. So that would be simplified. Okay. Feel free to work ahead if you're understanding this on the next one. I'm going to give you a minute to try the next one on your own. All right, I guess it wasn't a minute, it was 30 seconds, but hopefully the square root of 9 is 3, so I'm not going to break that down any further. I can take it out. I am going to already have that as an even exponent, so I don't need to rewrite that. What I'm going to do with the y to the 19th is I'm going to rewrite it as y to the 18th times y. So I like to take my highlighter, and then I'm going to highlight the things that I'm going to be able to take out from the square root. And it's those first 3 things. The square root of 9 is 3. The square root of x to the 10th is x to the 5th. The square root of y to the 18th is y to the 9th. So those 3 are simplified now on the outside of the radical, and the square root of y has to stay inside the radical. Okay. Next, what do we do when now these are cubed roots? These are definitely more difficult, okay? And so what we're going to have to do now is, instead of these were square roots, so these had to be written as even powers. Cubed roots have to be written as multiples of 3. And I'll kind of break this one down a little bit too, so you can see it a little better. So also the numbers would have to be, instead of perfect squares, to come out would have to be on the perfect cubes list. You're going to notice 27 is a perfect cubed. The cubed root of that is 3. So I'm going to show this a couple different ways. In order to take things out of a cubed root, there needs to be the factor multiplied by itself 3 times. So in other words, this means 3 times 3 times 3. I can take out all of those, okay? A times A times A is A cubed. I can take all of those. I need to write B to the 6th as 3 factors. How would I do that? B squared times B squared times B squared. Okay, so this simplifies to 3AB squared. Some people like to think of it as you're doing this. Another way of thinking of this is, okay, you're raising those things to the 1/3, so you're taking 3 to the 1/3 would be the degree 1, b to the 6 to the 1/3, 6 times 1/3 is 2, and so on. So that's another way of thinking of it. But ultimately, this time I'm writing these as multiples or multiplied out 3 times, rather than I was telling you here, the square root of x squared is x, and the reason why is because x times x gives you x squared. Okay, so with the cubed root, that's what we have to use. All right, let's take a look at this one. So 24, I'm looking for a perfect cube that comes out that goes into 24. I think it's an 8, so I'm going to rewrite this as the cubed root of 8 times 3. X squared I'm stuck with. There's nothing I can do there. Y to the 6th, if you're thinking of y to the 6th, I'm going to leave it like that. If you want, I can write it out this way. I can take out, but y to the 6th, I'm going to be able to take out as y squared. And z to the 4th, I'm going to this time write as z cubed times z. So I'm looking to make these, instead of even exponents, multiples of 3, because that's what I'm going to be able to take out. So the cubed root of 8 is 2. 3 stays under. Can't do anything with this. The cubed root of y to the 6 is y to the 6 divided by 3. That's y squared, or think of it as y squared times y squared times y squared is y to the 6. The cubed root of z to the 3rd is z. And what has to stay under the cubed root is 3x squared and z. So this is 2y squared z times the cubed root of 3x squared z. Okay. And this is a skill that you've probably never seen before. You've probably done some of this, maybe with some numbers in Algebra 1. Well, what do you think I'd have to do then for a 4th root? So a 4th root, the numbers would have to be on the perfect 4th root, and these exponents I'd have to write as a multiple of 4. Excuse me. Okay. It's impossible to write a to the third as a to any exponent bigger than 3. So we can't get it to be a 4. This is b to the 4th, which is great. I need an exponent that's a multiple of 4. So I'm going to rewrite c to the 7th as c to the 7th as c to the 4th times c to the 3rd, excuse me. And so the only things I can take out here are things that are exponents of 4. So the 4th root of b to the 4th is b. The 4th root of c to the 4th is c. And everything else has to stay under the 4th root. So 25, a to the 3rd, c to the 3rd stays under the 4th root. Okay. So, next. Simplified embedded radicals and rational expressions. There's a couple ways that you can handle this, but I guess how I would handle it is I am going to kind of do a mixture of writing them as fraction exponents and then also kind of thinking about what the radical means. All right, so I guess what I'm saying is I'm trying to look at what the end result is, which, like in this one, I want it to be in exponential form. And so kind of going back to what we talked about yesterday, whereas understanding that a square root is raising something to the 1/2, a cubed root to the 1/3, and so on. So this all the way in here has a third root around it. So 64x to the 6 has a 1/3 is the same thing as the cubed root. A square root is the same thing as the 1/2. So you might think, gosh, we got kind of a lot going on in here. And so I'm going to try to see if I can take out anything. And you can use some calculator stuff with this as well. But the cubed root of 64 is a perfect cube. The cubed root of 64 is 4. So I'm going to first address the cubed root part. Okay. Then I'll address the 1/2. And so that's a 4. And x to the 6 to the 1/3, or the cubed root of x to the 6, you could think of multiplying those exponents. 6 divided by 3 is 2. So this would be 4x squared. I still have that 1/2 up there. Now this is a square root situation. And so if you want to think of it as a square root, you can. But 4 to the 1/2, or the square root of 4, is 2. And the x squared to the 1/2, or the square root of x squared, is just x. So this simplifies all the way down to x. Okay, let's take a look at example 7, the second one. Looking at this much simpler, can you write this as an exponent? That's what I'm going to be asking you to do on your homework, okay? So what this means is the cubed root is I have x squared. By the way, the squared, I'm going to show you, can come first or second, and the cubed root is to the 1/3. The only way I could write that is x to the 2/3. Now, what I want to show you is it doesn't matter which portion you do first. So what if I did x to the 1/3 first and then squared it? Still, a power rule is going to be x to the 2/3. So they simplify to be the same thing. Okay, you also are going to see some things today on your homework where I ask you just to write it as an exponent again, where you're not going to have any numbers to simplify. So I start on the inside with my x to the 5th, and I move out and I see that's a cubed root. What exponent is that? Well, it's the 1/3, you say. And then, so I've addressed that, I go one more out and there's now a 1/2. Well, what if you have a power to a power to a power? Then you multiply all those exponents together. 5 times 1/3 times 1/2. Okay, let's remember here. That's what I'm doing. 5 times 1/3 times 1/2 is 5/6. So this is the same as x to the 5/6. What's the value of y? Y equals 5/6. Okay, so there's a little bit more of a challenge of simplifying some radicals, and then also going ahead and rewriting back and forth between radical and rational exponents, but maybe just a little bit more difficult than you saw earlier on your homework.